Welcome to ClickMyProject.com. Now we can going to discuss about the product single phase bidirectional H6 rectifier inverter. And next we can going to discuss about the abstract of our product. The proposed system is using the transformerless photovoltaic system. In our photovoltaic systems are using the bidirectional inverters because of the we can load side and the consumer side we can using the bidirectionally, but in our existing system we can using the H5 and HERIC inverters. These transformerless PV inverters should not have the bidirectional capability for the photovoltaic system, but we cannot the proposed systems are using for the H6 inverter. We can the bidirectionally act on to source to load. We can getting the backflow approach. Then we can advantage of our bidirectional techniques. We can using the select of H6 power stages. We can implement the topology for only modulation stages modified. And another we can saying for the one bidirectional rectifier and inverter modes of excellent level for the drain mode voltage features. This leakage current also issues some eliminating harmonics. We can improve the modulation index. So our simulation results are verified to the single stage bidirectional H6 inverter technique. Next we can going to discuss about the flow diagram of the product. First we can see about the irradiance. The irradiance is nothing but we can getting the solar sunlight. So some amount of levels we can getting the irradiance level. Water we can given the based on the our sunlight. So we can input of the irradiance level 1000 based on our photovoltaic system is an solar panel. Solar panel is an nothing but one of the renewable resource, and this is one of the best renewable resource in the world. So we can using the 72 cells solar arrays, we can specification of this solar panel, and this solar panel generating power of fully DC. The DC is passed to the maximum power point tracking technique. This technique is one of the famous technique for the solar panel. So we can getting the maximum power out we can getting for solar panel. So we can some technical ways using to the our DC to DC boost converter. This boost converter we can getting the almost we can getting the boost up level of our solar panel DC power. So we can getting the fully the DC power of DC to DC boost converter, and this is one of the important step for the DC to AC converter. So this is an this converter act as an bidirectionally for the our source means our solar panel, and receiving side means our AC grid. We can store the our energies, and these converters and act as a very efficient process for the H6 converter power stages converters. So we can using the intermediate sections for the this MPPT is technique. We can convert to the duty cycle pulses. The duty cycle pulses are passed to the our DC to DC boost converter. So we can getting the maximum of power in solar panel, and this section the DC to AC converter for that these triggering pulses are generating based on the sinusoidal pulse width modulation. The sinusoidal pulse width modulation to input reference of the sinusoidal pulse width modulation using the PID controller. So this is one of the chain process. For that everything is connected to some reference values we will given to the our triggering pulses, and the sinusoidal pulse width modulation also taken that, and so we can triggering pulses we can control the our DC to AC converter. So this is an act on bidirectionally. In case we can getting the very weak grid of the receiving side, so we can connected for the this triggering pulses. It AC grid also most weak to the high level we can generating the store of power. In case we can receiving side of the source side we can getting the power, so we can reverse side of this direction this off source side we can getting the similar as per vice versa we can store that power for the our source side. Next we can going to discuss about the running procedure of our product. The proposed system implementation done in Matlab version 2018b. We can see for the circuit diagram of the product, and corresponding scopes are connected from the two functions. This is our circuit diagram of the product. We can using the similar that we transformerless solar panel using that, and the converters, and we can grid water we can something to the, and the corresponding scopes are connected to the from two functions. These are from two functions. Next we can going to see for the discuss about the results. This is the grid voltage we can getting the nearly for 2
240 something we can getting that grid voltage. And this is on our VDC. Early VDC are getting for the step up process, we can automatically gradually increase together. So you can getting the maximum of VDC, you can getting nearly some 100 VDC, you can getting the for VDC links. And another we can see discuss our results. These are the our switching voltage and current. We can switching voltage nearly gradually ups on nearly 200 above because of our voltage and high, and voltage high means our VDC links are very high for nearly 700 voltage something we are getting that result. So we can gradually increase the switching voltage, and this is our switching current, very low current for this because of our injection current will be very low, but our voltage is very high, so it will inversely proportional to each other. And this is our similar that our VDC side, and this is our modulation index. This is our switching pulses. We are getting the very different duty cycle pulses. For the we can see about the half of the duty cycle is a very dense wave, and you can see the receiving side of the dense wave is also different. So we can switching bidirectional switching pulses, we can act as on these specific areas. So I will just zoom on this process. Yeah, we can see we can have the 6 switches, and these are very random something triggering pulses. This is an like inverter process, so this type of triggering pulses using that, and duty cycles are very same because of modulation index are very constant, so we can getting constant duty cycles. And receiving side we can see duty cycle ratio is very small because of we can sending and receiving side of the bidirectional converter, so we can very small duty cycle of this section, and beginning section is very large. This is our solar panel results. Nearly we can getting the solar panel results of 120 something, we are getting the solar voltage, and this is our current, and this is our photovoltaic diode. This is our maximum power point tracking result for the duty cycle to the pulse DC to DC boost converter. So this is getting the triggering pulses of the boost converter. Another thing on the result is our efficiency curve. This is an inverter mode and rectifier mode, so we can different combination of result to getting these plottings. These plotters are for using the our sim mode from the scope result, so we can just plotting for the efficiency calculation to getting that this plot figure. Thanks for watching.